I tools? Cat. Nice. Where's my change? My studio. Here it is. Content. Live. Let's clear this forever. Okay. Dealing with YouTube stuff. Okay. Nice. I think we're good now. How do I snap? Yeah. Alright. Move myself out of the way. Just for the thumbnail. Ooh. Okay. Alright. Let's begin. Let's do this, alright? So arrays are my passion. Okay, save this. Tap. So what we're gonna be doing today is these three problems, and so let's begin. The best time to buy and sell stocks shows up. And this is the solution, but hey, I just want to see if I can figure it out without help now that I did it off stream. So best time solution. There's a there's a tab. One tab. All right. There we. All right. Here we go. Let's begin. So what this problem is here is we are trying to figure out the best time to buy and sell given an array of prices. These prices can see here, we can do a visualization of how this works. So you think about this like a stock market. The stock market, you see the price of Nvidia, for instance. That. Alright, so the best time to buy would be right here, and sell would be right here. Alright, sell. This is a buy. And sell. Because it's peak. That's where it peaks. But the way we want to represent it is in an array. So the visualization of this is an array of numbers. It's show this would be the price would be say $10 beginning, and then we could have each point be, say, for instance, this, and this, and so do 15, 14, 13, then it goes back up 7 or 18, say 18, and then goes down to 17, and then we peak at $1,000. So you want to buy at the top, at the bottom, and then sell at the top, make profit of 900. Profit of 900. 990 bucks. That's a profit. There are multiple ways of figuring this out. You could do something like buying, or this is an array problem. You could think about generally array problems. Think about pointers. Pointers. How do you use pointers to figure this out? Also, there's an algorithm as well that you can use. So there's two potential ways of figuring this out currently that I know of. Looking at the solutions and stuff. And so the 2 pointers. Pointers. I say. All right, let's not spoil this. All right, so we do pointers. Want to use pointers? How would you use pointers to do this? So say you have pointer here, pointer A. All right, pointer A. You have pointer B that goes through the array. For instance, or here, B. So if you have 2 pointers, that will be what you can do. Or we can try to, what else we can do is have it here if we want to, then go back. But in this case, it seems like we want it next to each other. The rationale of it being, generally when you have 2 pointers from both sides, one on the front, one in the beginning, one at the end, generally it's when you're trying to find something that in an array that is sorted. Because then if it's sorted, you know that certain conditions will allow you to know which one to move. If you have a target or whatever. I guess you use binary search in that case. If you have the binary search is also 2 pointers. Yeah. So, and it goes from the beginning, or it has a pointer in the beginning and a pointer at the end. That makes sense. They're generally solutions for search or whatever would require a pointer in the beginning and the end. But in this case, yeah, it looks like this would work because you could have A, B, A points to this, B points to this, and then if B just keeps on going, we know that A is the lowest. For instance, if we know A is the lowest, all we have to do is check which one will profit you the most. So you could have B just go all the way to the end, and then find that 1,000 is the most, and then we output how much profit we get there. So that 2 pointers is that's what we can do. The 2 pointers with lowest value, or with the buy and sell pointer. So this is a buy and sell pointer. The buy, and this is a sell pointer. And this will if you do a max on all of them, then you will be able to figure it out. This is how, if you do, this is how I would say easily solve it. Yeah. And then another way of doing this, of representing it, in the same way, in a similar fashion, is when you look at this, you think about if you're a stock, right? This is a continuous graph, or continuous graph, because it's going from one side to the other, and you're pretty much adding and subtracting values as you progress the day. So this is a contiguous, pretty much, you're trying to find a contiguous subarray, the sum of it, which gives you the highest profit. Because you could do that. And this subarray, the sum of this subarray, will provide you what you need. So that's the second. The sum. So buy and sell pointers. Buy / sell. And then you can also do a sum of a contiguous subarray. Because you could represent this problem as the buy and sell problem as a subarray, contiguous subarray that you are summing up the values of. So contiguous subarray, sum, so it's max sum subarray, max sum sub array. Let me just drag this guy out. Yeah. And this will be it. This is the two solutions that you can use to solve this problem. So let's write it up. Right? Let's write it up. So buy and sell, doing the buy and sell. This is thinking about the time complexity of this, time complexity, and the space complexity of buy and sell. So buy and sell, you're using pointers. Generally pointers O 1. But if you have a return array, it could be O of n for the return array. But this is not, you're not returning any array. You're just returning the profit. So it's O of 1. Yeah. There you go. And then for time complexity, it would be O of C. We're trying to choose buy here, right? The most we could do, if it moves here, if it stays here, then sell will move total of n, O of n. So that'd be O of n here. But then say, for instance, go here and you realize that it is slow. Is, say you have an array of monotonically decreasing. So say 1,987.6. Then the pointer for A here, Y is here, and the cell will be here. Then you'll go like this. Comparison, realize that it is smaller, so we shift this over here, and we'll go over here, over here, over here, and over here. So this would be 2n, which is simplified to n as the worst case. So let's delete this. But yes, it would be O of n as worst case scenario for this. And then for the max sum subarray, time complexity, O C. Oh my god. What would it be? So, max sum subarray. You're summing this part of the subarray, and then once it goes negative, no, it doesn't ever go negative. So if we do a different graph like that, this subarray, once it reaches negative, we'll start from that again. But that's pretty much just O of n at that point, because you're starting from the beginning again. And you're only going through this one time, or at most 2 times. So you're moving 2 pointers. At most, you'll be moving both pointers of n times, or n movements each one. So the max is 2n for 2 pointers when it's going through the entire array. So say it's O of n here, and space complexity is also O of 1. Yes. So max sum subarray, this is a Codain's algorithm. That's the same, it's the name of it. Codain. He figured out this thing where you clear everything to set it back to 0 once you reach the negative sum subarray. And then that's how you figure out the maximum sum subarray. You do that for the minimum as well. If you change it to negative, change everything negative, and then you change all the values negative in the array first before iterating through it. And then returning the value, and yeah. Alright. So let's write the code for it. For the first solution, the buy and sell. Buy and sell winners. Buy, sell. So this is the pseudocode for it. What you're gonna do first, go looping through, and then we have pointers, loop prices. Loop from let's see, how do we want to loop? So we're looping where such that buy is equal to, what should buy equal to? Buy should equal to 0, and then sell equal to 1. And we're looping to prices, looping prices. So the length of prices. So length prices, and I like having this here, so it's non-inclusive. Non-inclusive. All right. Now what do we do here? So we have a max. Move this over here at the top. Always have to initialize the variables like what we're trying to remove or what we're trying to return at the end of all of this. So what are we trying to return? Trying to return a couple things here. One being the profit. So if you have a max profit equaling to 0, I mean, this is obvious. So I think we should just, we don't need to set the values here, all the values, you know that. Obviously, you start off max profit at 0, so you initialize these variables. Let's simplify what we are doing here. So init to initialize it. So max profit, what else we gotta init? You're buying and then selling, and then you're checking that against the max profit. So you have a current profit as well. But do you actually have a current? You don't need to have a current profit because all you have to do is do the max buy and sell, and you can do a logic to either bump up the buy or not. So if okay, so you do buy minus sell or sell. No, this is buy sell minus buy. So you do sell minus buy. The profit equals. Oh wait, you do need a current profit. Yeah, you do need a current profit. Current profit. Alright, so you have a current profit. Zero. So you do current profit. But equal to yeah, prices. No, because we do buy and sell as a P. Prices buy minus sell. Buy minus prices sell. Or I mean sell minus prices buy. Minus prices buy. Just seeing if there's a way to make everything concise. Prices at buy. Nice, nice. And if we do that, we check to see if we compare the if current profit, we know if current profit is less than 0, we know to reset everything. So we reset the buy pointer. Buy pointer buy plus plus. Oh, no, not plus plus. Buy equals sell. Because at that point we know that we can jump to the next value. because that next pointer, because we know that that next, the place where you're selling at is would be lower, because at this point we know that sell prices at sell is less than prices at buy. So we found the newest, the smallest, smallest, and that's how you maximize profit, by buying it at the lowest price. So we want to buy at the lowest price, so that's what we set it. Lowest price. Cheap, because we have to be cheap. Buy equals sell. So what do we do after that? Brain is not working. But after we do this, we know that it's time. Update max profit. Update max profit. And then continue with sell plus plus. Nice. And then we continue return. And what will we return? We return max profit. Max profit. We be rich. This is how we win. Okay, nice. So this is what it means to this. If we do example of max profit here, current profit. Ooh. So max profit, current profit. Yeah, let's walk through an example, because that's one of my weaknesses, walking through examples. So if you say C10 of 10, I'm just looking at this here. So we start off with 10. And then here 10. And what happens when you have 10? So buy is equal to this half x, which is that, sell is equal to 15. Then realize our max profit and our current profit is equal to 5, because it's 15 minus 10. So let's visualize this. I gotta make it. Draw a box. Okay, here we go. So what we gotta do here is we have 15. Or 15 minus 10. And it outputs a 5. And that is our current profit. So current profit. Then we know this is 5. That we can update max profit. Max profit is now equal to 5 as well, which is nice. So now, after we get the update that we sell plus plus, so we point that sell pointer to 13. 13 minus 10 is equal to 3. So 13 minus 10 plus 3. So now the current profit is equal to 3, and the max profit is equal to 5. Continues to be 5. And then after that, we do shell plus plus again, which is 18. So 18 minus 10. 18 minus 10 is equal to 8. So now max profit is equal to 8. Then you do 17 minus 10, and that's 7. Max profit is still 8. 1,000 minus 10. Max profit is now, guessed it, 990. 990. And then we return where pointer is at the end of its ropes. Nice. Oop. Okay, so this looks fine. This works for this first example. Maybe we could make this down a bit. Now we could say this is one of our examples over here. Okay. What other example can we run through? Say we have over here. Also move this over here to example this. Nah, never mind. It's gonna be very messy. Let me move this over here somewhere else. Where should we move? Move it over here. Okay. So this is example 1. I don't know if you can even see it in the recording. It's small. But here we go. That's example 1. Now I'm going to do example 2, which is we do an empty array. That's still fine. Okay, let's do some edge cases here. So empty array. Then if we have is empty array even possible? Because the constraints is 0 versus at 0. No, empty array is not possible. It could be 1 though, where the max profit is 0. And then what else is there? There's not really anything else. I mean, this is balancing. Oh yeah, there is. So you gotta see if you this logic income. This is the something like this: 10, 15, then 9, then 30, then I think that's no, that's 930. But if we do 98, 30, then we know what is the best option. Which is yes. I know what the best option is. 30 and 8. So this would be outputting 22. So if we do this example here, current profit and max profit. So current profit is equal to 10 or 15 minus 10 over 5. Do 5 like that. And then we do 5 and 5. Okay, and then do 9 minus 10, which is -1. And at that point, we reset. We set the, since its current profit is less than 0, update buy to equal sell. So buy is now equal to 9, which means do 8 minus 9 here, and output being -1 again. But we know for sure here all 5 is still 5, so we don't have to update anything there. But then we know that 8 is now the lowest. Now we do 30 minus 8, which is, as you guess, 22. And 22 is the new max profit, as we update max profit. Now we do 2 minus 8. That is a 6. My book, -6. And we are stuck with 22. Max profit return. Yeah, we remove this part, makes it more to understand. There we go. Perfect. Max profit 22. Nice. So that works for this case. Okay. And this over here works for this case. And this last case, does it work for it? How do we know? Let's see. Try it out. Only way to find out is to try it out. So this looks like a out of bounds error. Because now at that point, yeah, we need to check to see if it's less than 1. I mean, if it's less than 2, the length is less than 2 of the prices, then we have to return 0 because you can't sell it. Only buy diamond hands forever. So yeah. You know what that means. You don't win if you don't sell. Yeah. That's how it is in life. Until the tax man comes, you have not made profit. At least this is what this problem is saying. So, yes. 0. What do we do here now? So, we update our code to handle the edge case. If length plan of profit less than 2. No. Return 0. Alright, perfect. So now this should work. This is our code. This is part 1. The other part here, to the right of it, we shall, try max sum subarray. Yeah, let's hop over to our friend Leetcode and try it out. Alright, let's see. Speed up your brain, go faster. Move it, move it, move it. Where are we? Browser? Yeah, got me. Browser, here we go. There we go. Best time and buy and sell. Donks. Right. I mean, you already see the solution here, but let's clear it. Because we are like that. We enjoy a challenge. So what did we just do? First off, we have to set the initial variables. I mean, we do the base case actually. If length of prices is less than 0, less than 2, I mean, we return 0, and then we shall initialize our variables. What do we initialize? We initialize max profit equals 0. We initialize current profit equals 0. But at max profit, we have to do maximum profit. It's cool like that. And then, what do we do now? We do a loop. We like loops. What do we do with the loop? So loop, we're looping with 2 pointers. Looping with 2 pointers, buy and sell pointer, to be precise. So buy equals 0, and sell equals 1. And then for loop. While loop. While sell is less than length of prices. And we continue. What do we do with that? We do a set current profit. We set current profit to equal prices at sell minus prices at buy. Because you know why. You gotta sell what you buy. And then after that, we have to check to see if the current profit is less than 0. So we would want to reset the buy. Our buy index would now equal the sell index. Then yes. Now that it's reset, there's also always you have to do sell plus equals to 1. Have to bump it. But you also have to update max profit. maximum profit is now equal to maximum of maximum profit, comma, be a boy for profit. And then we could return maximum profit. Perfect. There we go. As planned. Now let's go back. Let's clear this. Clear this. Clear this. Hi, browser. And let's continue. We have to do our maximum sum subarray now, so that is the fun part. Maximum sum subarray. How do we do maximum sum subarray? So max sum sub array, aka Kiddanes. Pretty much you're resetting everything back to 0, just the same way as what we did before, but we're doing it for the sum of array. All right. Yeah. All right. So what do we do here? We loop, but we also have to init some variables. So we do init. But first, yeah, let's think about what variables we need in the loop, and then we're gonna do the init values. But we have start and end. Start and end of the subarray. Start equals 1, commit 0, end of the subarray is equal. Actually, do we need start and end? We only need, because we don't need to output the subarray. That would be a different problem. We're only outputting the max profit. So in this case, we could say hello to single pointer. A a lot of us out here single pointers. All right, single pointer. What we do with single pointer? Well, what we do with single pointer? We jump it and we set it. So what does the pointer do? Sir. Okay, we say I. All for I equals 0. I equals 1 though, because you gotta do the cell. So I has to start at 1. You gotta cell. And you gotta cell. So you gotta track the previous value. Yeah. We're also going to the line of prices. And we're also non-inclusive. What we're gonna do here is initializing our current profit and max profit. We want to make consistent max profit and current profit. Nice. And what you're gonna do is we also need this. Because at this point, you know, it's the same thing in here at the beginning. Profit is less than 2. Oh no, less than 2. What we do wrong. Parentheses. Less than 2. Then we return 1, 0, 0. Yes, we gotta slow it down. So loop 1 I equals 0, 1. What we do here is we set current profit, same as current profit equals prices at I minus prices at I minus 1. And then we have a max profit as well. So if, so how do we, okay, so we could do max profit now. We could do a reset max. Oh wait, current profit is that it hits max. I remember we had to do a max at the top as well, but do we? Let's see, the max profit equals the max profit of 0. I mean, current profit equals current profit plus. Yeah, it has to be plus equals to. Plus equals to. Because you're adding. I think I know now. I remember. This is coming back to me. Current profit now is equal. When you think about it, you're either you want to reset it to 0 if it's less than 0, so max. This is so much stuff in here. All right. You know what? Let's do this. Let's make it easy. Let's make it easy to read, so we don't have everything chunked up in one place. So we could say this is new or next sub profit. We do a sub profit. This is the sub part of the profit. It's now equal to that. So current profit is equal to max of 0, because I start at 0. So that you can't go less than 0. That won't be a profit anymore. You won't be profiting. You'll be losing. You don't want to lose. So in that case, do a current profit plus sub profit. And then we have max profit will now equal to max of current profit and max profit. There we go. And then we return max profit. I think this is it. But you know what? We have to test it. So let's test it. So we know that this base case here is easy done. Easy done. This is yoik. This case is so we know that that's done. Gotta do this one. Majari Copy this. And copy and paste. Copy and paste. The true programmer. Paste it over here. Okay. How do we flatten again? Shift M, right? Let's see. Tab M E. Save. Tab. Alright. Erase. No, that's not what we wanted. Wait, is he solo this? Alright. Alright, I pretty sure. Alright, we just said, yep. Just shift Alt M. That's what I set it to. Tab here. Let's just merge the layers. Trying to be good. Studio Painter. So, us. Okay, so after this, remove this and remove this all. Erase it. Erase. Erase. Yeah. Nice. So yeah, so what we gotta do now is run through our logic for this. So we do loop 0 raised by itself. And by it's not here. So the I. Okay. Okay. Alright, so current profit is equal to 15 minus 10, which is, guess it, 5. What do we do with that? 5. We'll bump it up, bump up the numbers, man. So 15, let's do, instead we do 13. 13. Okay, so then we just sum it, 13 minus 13 minus 13 minus 15. 13 minus 15. So 13 minus 15, what is that? That's 2. But then you add a plus. There's negative 2. Oh no. It's negative 2. So negative 2. And this will add it up since we're adding it together with this. Negative 2 is 3. Now 18 minus 13. 18 minus 13 is 5. So we add that together. Just 8. And then, yeah, 8, because this is 5 plus 3. And then 8. 17 minus 18 is -1. So you know what that means. That is 7. Then we do 1000 minus 17, which is 983 plus, yeah, so that's 990. Go to 990. This is the solution. Here we go, perfect. And then over here, we do 15 minus 10, which is 5. 9 minus 15 plus 5 is -1, which is 0. Because we set it to 0. Set it to 0 if it's less than 1. Then 8 minus 9, -1. That's also 0. And then 30 minus 8, 22. Welcome to the right 22. So that's how you do it. 22, and it works. All right, let's go over to our trusty code. Guy off. We pop this off and work on this. And we clear it. Hey shit. Hey, oops. You know, dropping things. Clumsy as. Okay, let's clear this guy. So you know what this is. So we do a for loop. I equals 0, or I in range, length of prices. But then we don't want to just do that. We want to start off at 1, because so sub profit equals prices at I minus prices at I minus 1. And then we have current profit equals maximum of 0, sub profit, and current profit. Or current profit plus sub profit. Then we have max profit equals maximum profit equals max of current profit and max profit and mum profit. Perfect, there we go. And that was a bit slower than the previous one, but it's the same speed in terms of complexity. Here we go. There you have it. Alright, let's go to the next thing. Yeah. This is actually so much better now that I ran through it once and twice. Everything makes sense. Everything here just makes sense. Okay. Let's close this guy out. And yeah, there we go, there we go, there we go. What am I doing here? Drop this. Okay, 0 mistakes for that one. Let's do majority element. And then majority element. To majority solution. So you know what that means. Okay, so majority element. What it's trying to say here is what we're trying to do here. Getting uh, trippy here. Now that we're settled here, tab. So pretty much what's happening is trying to get majority element, major, most element, the element that has the most ris, the element with the most group, the most groupies, the most biggest group. So okay, how will we do that? Let's think about it. One way is that you can sort it. So you could do two, right? If you do sort it and you just split it in half, let's try it right here. So it's, if we sort this, 2, 2, 2, 2, 1, 1, 1. Erase this boy. 1, 1, 1. If we do length divided by 2, we get this guy. Length as being 7 divided by 2 is 3 in this case. And if you do integer division, that'll be 3. And it'll point here. Alright, so what are you doing math stuff for? Length divided by 2. And that majority element. So that would what sorting does. Sorting majority major. So what we could do is sort plus mid. Sort plus mid. Of course, you know, time complexity is O of n log n. For sorting algorithms, always that. You find the middle, you find return it. I mean, depending on how you sort it, it could be different space complexity. I think heap sort. Is heap sort? Oh, what's the space complexity of heap sort? Space complexity of heap sort. It's an in-place sorting algorithm, so it's O of 1. And then time complexity of heap sort is also O of n log n, all cases. So heap sort, this would be it. And why would you use heap sort over all the other sorts? Why heap sort used? Or why would you use heap sort? So heap sort to manage memory allocation, but the best reason, why to prefer heap sort over other sorts. The memory usage minimum. Okay. So there are other algorithms that you can use that can optimize the average case. this is pretty good overall. You just use heap sort for this. You want to maintain this space complexity. G sort. Okay, so what do we do now after this? We also want to make another. See if there's any other way. There's a majority thing algorithm, Moore's majority algorithm or something, that some sort of majority element algorithm. Moore's majority of vote algorithm. Boy or more majority element majority algorithm. Boyer-Moore's majority vote algorithm. Boyer-Moore. Be more of a boy. Boyer-Moore algorithm. Boyer-Moore complexity. The voting algorithm. Voting. We know all these are just algorithms, so we just say Boyer-Moore voting. Here we go. So those are the two algorithms that you can use. And erase this boy here. Move this up so that we can say time complexity. Time complexity being let's think about what Boyer-Moore does. So you can do an O of n, right? It is O of n because it should be O of n because you're going through each number. Boyer-Moore. That's what you do. So you go here for each number. You're like, hey, majority. So current majority element will be 2 at this point. And then at this point, majority element is 2. Let's move this up. Let's look at the other one instead. Let's look at this one instead, right? Oh, 1 second. Yeah, that'll be like that'll be the example here. But what we do here is, you say 2 majority, then you do +1. And then whenever you have a different number, you do a -1 and a -1. And then the majority would still say it's 2. And then once you go negative, then we change the majority element to be this guy, and it'll bump it up to 1 again. So 1 frequency. And then we go here, and it goes to 0. So the majority element is still there, and if you increase the frequency again, or decrease the frequency again to -1, then we set the highest value to be 2. Okay, perfect. I mean, so let's create the algorithm. So let's write up the algorithm. I mean, space complexity in this case is O of 1 because we're only using one. We're only going through. We're not storing anything. It's returning one number. It generally is O of 1 if you only have pointers and not an array. So we do Boyer, do Boyer, copy, paste, and then move Boyer-Moore. Okay, so Okay, so with Boyer-Moore voting, how do we do this? We have initial variables. We also have the loop. Okay, so what are we initializing? Yeah, or what are we looping? So we're looping in and we're checking. We have index is equal to 0, I equals 0, and then we're going through to range of length of nums, and it goes to the end, non-inclusive. Yeah, let's just do that. Non-inclusive, right? Nice. We do that. Inclusive at 0, non-inclusive at that. Okay. What would you initialize? There's nothing really. I mean, do we? No, we do initialize something. We have to get the majority element. It's a majority element. Majority element. Majority. Major. Then we also have a frequency. And we have a frequency. Alright. I mean, we could start, instead of starting at 0, we could start at 1. And then we could have majority be equal frequency equals 0, and we could have majority be the first number. So nums. Should be. Alright, let's go over here. Majority equals nums. What do we do here? Num of 1, of 0. Yes. First number. And what are we gonna do now? This frequency is also equal to 1. Yeah. So now if there's a number, so if num, okay, so we have current equals to nums at I. And then if current is less than, no, it is equal to major. So we update it. Else, so frequency plus plus, else it's not equal to, so frequency minus minus. And if we have less than 0, frequency less than 0, we will say, hey, majority element is different now. Majority is equal to, you know, current. And also, we want to increase the frequency to equal to 1. Ooh. Frequency now is equal to 1. Yes. Yes. Okay. So that's setting everything up back up again. There's just too many symbols. Say update frequency. Yeah. But I guess Python is kind of like pseudocode, so there we go. Yeah, so it's pretty much just resetting it back to the other one. Then it goes back to the top. And what do you do with the top part? It says, hey, it's equal to major again. It'll add and also it'll subtract. And if it's less than 0, then we'll switch it. And then we'll return the major. Perfect. That should be the best way of doing things. And sorting is easy. I mean, if you use the sorting algorithm, that's the built-in sorting. You say that's done, and then you just do this 5 by 1. So all we need really is Boyer Moore's voting. This is it. This is it. So let's try some examples. Let's test cases. Tests. So test cases being empty array, and then we have 1, 2, 1, and then 2, and then we have, what else is there? 2, 1, and then 1. Then we could say 3, 1, 4. Yeah, what if we, yeah, I mean, yeah, what if we do have just totally different things? Would it still work? I wonder. So, let's see. So, you know the majority element here, what each majority element would be. This is nothing, of course. Oh, but this says that we will not have length of, yeah, nums n equals nums dot length. Nums dot length is between 1 and whatever. So the most would be that, be 1. In this case, would be 1, 1, 1, and then any. Oh, you may assume the majority element always exists in the array. So there always has to be a alright, fine. This will be 3. Alright. Let's run through it. So 1 goes through here and says, hey, I have 1 to the length of num, so 1 to 1, which is yeah, it just returns 1, of course. So the top part works already. It won't even loop. So that works. Check mark. And then so this part 1, 1, 2 starts with 1. And then what do you do with 1? Let's visualize it, right? So 1, 1, 2. Current nums is equal to 1. Wait, 1, yeah. So your frequency is equal to plus plus. Yeah. Yeah. It's better if we have more space. Alright. We got it now like this, so. Alright. So 2, 1, 1. What we do here is frequency plus plus and major. Yeah, frequency and major. So you have something like that. Frequency at the beginning is 2, no, is equal to 1, and then major is equal to what is major equal to? 2. Okay. Then we do 1 comes 0 comes 0, negative 1, and then becomes back 1 again. And 1. Okay, nice. Because the reason why it goes like this is because, yeah, at this part of the code, it's checks. It says, hey, if it's less than 0, we switch to major, and frequency is equal to 1, so that's why this, yeah. Frequency, major. So frequency is equal to 1, no, 0, no, 1, starts at 1, and then starts at 3. Okay? So now 1 goes to, what do we do? 0. Because it's different from 3. And after that it goes to negative 1 and becomes 4. 4 becomes the majority element. And then after that, 3. So there's an issue with the code, you see? Because it goes there to 0, it doesn't become 3. But it should be 3. Yeah, it's not really majority element because, yeah, at that point. Yeah. So this is still right, Majority element is not 3 in this case in the way that it says. So that's n divided by 2. That means that we need 1 more 3 in order for the majority element. So 0, 0, 1. And comes back 3. Perfect. Then frequency. Frequency and major. So frequency is 1. At 1. 2. And still a 1. Then it becomes a 1 because it subtracts that from 2. And we still have 1. Perfect. Alright, it's time. Oh shit, this pen is so rolly. So let's go over to our coding page. Where is it? The majority element. Let's go. Open up. Nice. Now we'll go here. Now we fully understand majority element. Let's go and code it up. What does it say? So we have to initialize the variables. Major equals nums at 0. And we have frequency equals 1. And then we have a loop that goes through for I in range 1 length of nums. Then major, no, frequency, if nums at I is equal to major, what we do is frequency plus equals to 1. Else no C minus equals to 1 if frequency is less than 0. We shall set it to frequency to equal to 1 and the major to equal to the new value, which is current. Then we have current. Current equals set 0 I. Then yeah, since you set it, that's all you need. Then we return major. Perfect. There we go. Just as we anticipated. Alright, so we're done. Oof. Let's go back. Let's go back. What time is it now? Intervals. This one is pretty tough. This one is pretty tough, bro. Interval. I don't know if I can do this, but we shall see. Insert interval. Here we go. Insert interval. And solution. Then we have go. Let's think it through. Let's think it through. So insert interval. We're trying to insert an interval into a group of intervals, and we're trying to merge them if they are mergeable. They look mergeable. They overlap. They're mergeable. We merge them. I think it's time to sleep. It's time to end the day. Yeah, just as we were at the good stuff. I thought we still had time. We did not have time. We'll work on this tomorrow, because I know for sure this is gonna be legendary, very difficult. No. Thanks for joining my stream. And we'll see you on the flip side. Alright? Better be good. Do Leetcode. Do your dailies. Alright, see ya.